Do you need to run tolerance simulation and analysis? Let's talk about DCS next. Okay, so let's talk about Dimensional Control Systems, DCS, and their product 3DCS, which is a tolerance simulation and analysis application. So first off, this tool can run as a plugin to most of the mechanical CAD applications that are out there, NX, CATIA, a bunch of other ones, or it can run independently. And we'll walk through the workflow here in a second, but running is independently or standalone is actually important because you might be getting parts from multiple CAD applications and you might need to bring them together to run the analysis. So let's walk through the steps of the process and how it works, and that will kind of expose why this tool is a little bit different. So first off, let's walk through the setup. So what you can do is you can read the geometry and the PMI or other tolerance information that you already have in your CAD application. Okay, so and there's a separate definition for what you're going to be using for your simulation and analysis, because you might need that to vary a little bit from the original definition. Okay, so you read that in, you bring in all your PMI that tells you how individual parts are going to vary, and then you define how parts are going to be connected or assembled together, right? Which will determine the stack up for the tolerance analysis. Okay, so once you have that, you kind of read that in, you can then determine how you want, if there's anything missing in terms of a tolerance, if any of the existing tolerances need to be tightened up or loosened, right? You can do that in the separate definition that's part of the plugin, part of the standalone tool, okay? And as a nice kind of visualization of that, you can press this little button that says deviate, and you can see the surfaces of the part that have tolerances on them move slightly, they animate. You can see that happening throughout your assembly. So it gives you a nice visualization of how the parts are going to be varying per the tolerances in the assembly. Okay. The second key capability or step here is iterating. So if you make a change in your original CAD application to the original geometry or the PMI, you can propagate that change down into the definition you're using for your tolerance simulation and analysis, and vice versa. You can push up or down on that, which is good because you're going to want to iterate, you're going to want to explore different alternatives and different possibilities there. The third thing, or the third step that happens or occurs, is you actually run the simulation. So after you've kind of defined all the tolerances, you press simulate. It actually runs a Monte Carlo simulation where, according to the distribution you define for each tolerance, you know, think about a bell curve for each tolerance, it will then do a calculation of where that tolerance falls for that particular iteration. And then it will do the stack up analysis according to that. And you can tell it to run as many of those as you want. So you're getting a statistical variation that, that represents a number of assemblies that you're bringing together, right? You can then analyze that. You can see, okay, so for whatever measurement you define, say a certain clearance between two parts, if it exceeds that minimum, then you have a failure. So according to the analysis that 3DS runs, it then will tell you what percentage of your assemblies are going to fail, right? According to quality criteria. It will also give you attribution to which tolerances and which connection points, which assembly points contributed at the highest rate to those failure rates. Okay, so now you have a root cause analysis. Now you can go back and start making modifications, and this is where that iterative process starts to come into play. You can make changes to the geometry and the PMI, bring it down to the definition DCS is using, 3DS is using, and rerun that simulation. So that's all well and good and interesting. That kind of gives you the analysis along the way. that an engineer can use to make the right decisions so that you should have good manufacturing outcomes. But it doesn't stop there. There are extra steps that you can go through. So for example, you can export all of the touch points, all the measurements that you want to follow that are going to be criteria for success or failure. You can export that, and that can be imported into your CMM application that is used to program the CMM equipment and the touch points. So once you have that, the CMM equipment can then take measurements on a batch, a small batch, large volume of parts and assemblies, and capture that data in basically a CSV file. You can then import that back into 3DCS, back into the same environment where you ran your simulation before, and you can look at basically the same exact analysis, except you're looking at real physical quality measurement data as opposed to simulated quality measurement data. Okay, so now you have real world data, you're running the same type of analysis, same type of attribution. You can make changes if you want to, go through that closed loop process and get better outcomes. Another step, they actually have another application, a quality data management solution that will manage quality data in batch. Okay, so it will capture that over time. You can actually plug the 3DCS tool that runs in your CAD application or standalone to look at that data and actually use that over time. So it's not just small batches of CSVs that you want to bring back in. You want to monitor it against the actual production data, quality data that happens over time. So as you can see, I mean, there's a good closed loop going all the way from the design and kind of doing that stack up analysis and simulation to make better decisions up front. That can feed the CMM programming step. You can track that against small batches and kind of make better decisions there with the same tools. And then you can track it against large volumes for the quality data management solution that they offer as well. And this is one of the few providers out there that kind of offers all of this in an integrated suite. So that is one of the big differentiators that they have. Another big differentiator that they have is the simulation aspect. So running the Monte Carlo simulation against all the tolerances according to a distribution that you define and seeing what the failure rate is and getting attribution, and then that enables you to make better decisions up front. So there's a lot to like in this tool, and there's tools for engineers up front, there's tools for quality people on the back end. So there's a lot of capabilities there. That's it. Thanks for listening. Take care and talk soon.